Input-output tables. An input-output table gives pairs of numbers that follow a certain pattern or rule. For example, in this input-output table, the rule is that 2 has been added to each input. To determine the rule for a table, simply look at one pair of input-output numbers and figure out what number has been added, subtracted, multiplied, or divided by it. Then, make sure that pattern matches the rest of the numbers. Once you know the rule for a table, you can finish filling in the rest of it. Look at the input and apply the rule. For example, if the rule is subtract 5 and the input is 9, then you subtract 5 from 9 to get 4, and 4 is the output. Examples. What is the rule for this table? Looking at the first pair, 5 and 15, we can tell that either 10 was added to 5 or 5 was multiplied by 3. Let's see which pattern works for the rest of the table. For the second pair, 4 and 12, we can see that 10 was not added, only 8 was added. But 4 times 3 is 12, so it appears the rule is multiply by 3. Let's make sure this rule works for the rest of the table. 2 times 3 equals 6, and 7 times 3 equals 21. So, yes, the rule is multiply by 3. If you needed to write this rule using a variable, you would say 3 times x, which can be written as 3x. Remember that a number next to a variable means multiplication. That's because x stands for the input. So the output is always 3 times the input, x. Find the rule for the table and finish filling it in. First, we must figure out the rule. What's happened with the first pair of numbers, 10 and 6? It looks like 4 has been subtracted by 6. Let's see if this rule works for the rest of the table. 8 minus 4 equals 4. 11 minus 4 equals 7. And 4 minus 4 equals 0. So, yes, the rule is subtract 4. What would this rule be written with a variable? It would be x minus 4, because you start with the x, the input, then subtract 4. Now we can fill in the rest of the table. The next input is 5, and the rule is to subtract 4. So what is 5 minus 4? 1, of course. This goes in the output spot. Now our table looks like this. The last input is 20, and the rule is still to subtract 4. 20 minus 4 equals 16, so that goes in the output spot. The final answer is that the rule is subtract 4, and the filled-in table is. Complete this table. The rule is divide by 2, then add 1, or written as a variable, x divided by 2 plus 1. In this case, we're told the rule and have to fill in the table. Notice that the rule has 2 steps. Divide by 2, then add 1. Let's start with the first input, 20. We have to first divide by 2, then add 1. 20 divided by 2 equals 10, and then 10 plus 1 equals 11. So 11 goes in the output spot. Now the table looks like this. For the next input, 6, we follow the same rule. Divide by 2, then add 1. 6 divided by 2 equals 3, and then 3 plus 1 equals 4. 4 is the output for 6. For the next input, 10, 10 divided by 2 equals 5, and then 5 plus 1 equals 6. 6 is the next output. For the last input, 18, 18 divided by 2 equals 9, and then 9 plus 1 equals 10. 10 is the last output. Which rule was made to create this table? Y equals 3x plus 4. Y equals 6x plus 2. Y equals 2x plus 5. Notice that the input is x and the output is y. To see which rule was used to create the table, we must test the pairs of input-outputs, x, y's, in the different equations. Let's test the first pair. X equals 1 and y equals 7. Substitute this into the first equation. Y equals 3x plus 4. 7 equals 3, 1 plus 4. 7 equals 3 plus 4. 7 equals 7. This works, so this could be the right equation. But we're not sure yet. Let's try the second pair in this equation. X equals 2 and y equals 9. Y equals 3x plus 4. 9 equals 3, 2 plus 4. 9 equals 6 plus 4. 9 equals 10. Wait, this isn't right. So this was not the rule used to create the table. Let's go back and try the first pair in the second equation. Y equals 6x plus 2. 7 equals 6, 1 plus 2. 7 equals 6 plus 2. 7 equals 8. This doesn't work, so this cannot be the right rule. It seems as if the table must be made from the last rule, but we want to make sure. So let's try the first pair, x equals 1 and y equals 7, in the last equation. Y equals 2x plus 5. Y equals 2x plus 5. 7 equals 2, 1 plus 5. 7 equals 2 plus 5. 7 equals 7. This works. Let's try another pair. Let's try x equals 2 and y equals 9. Y equals 2x plus 5. 9 equals 2, 2 plus 5. 9 equals 4 plus 5. 9 equals 9. This works again, so it appears this is the rule. To be positive, let's check the last two pairs. Test x equals 3 and y equals 11. Y equals 2x plus 5. 11 equals 2, 3 plus 5. 11 equals 6 plus 5. 11 equals 11. True. Test x equals 4 and y equals 13. 13 equals 2, 4 plus 5. 13 equals 8 plus 5. 13 equals 13. True. The rule used to create the table was y equals 2x plus 5. Here is the summary of the lesson.